Hi guys! Oh my goodness, it has been so long since I recorded an in-person science video or we did an experiment that wasn't a virtual experiment. So I'm excited to see you guys again, and I hope that we can do a little bit of fun stuff today as we start our unit on forces. And so today in our experiment, we're going to be observing forces acting on a falling object, which is what we've been started to talk about a little bit, right, this week and last week. And I thought it'd be fun to do this one because this is what I always enjoyed doing when I had you in class. So let's go ahead and think about what we're doing today. So if I drop something, like I've got my pen, and I drop it, what forces are acting on it? Well, what forces have we been talking about? Well, definitely the big one that you might have heard before. Gravity. Gravity is a force that acts on all falling objects, pulling them towards the center of the earth, right? Gravity is what keeps your feet on the ground, hopefully, and it puts everything where we like to have it here on Earth, even though we're spinning through outer space. So gravity is one that you've definitely heard about in other classes. But what about this one? Drag? Miss Hudson, what's drag? Well, it doesn't mean boring. Here, drag is a force that works against gravity. It's gravity's worst enemy. Drag are the forces of the air that as an object falls down, the air pushes up against it. Not enough to stop gravity from working because gravity's awful powerful. But enough that it pushes against it a little bit and makes it fall slower. So think about things that fall and things that use the air pushing against it to slow themselves down as they fall. Can you think of anything? A classmate of yours who's face-to-face said, Miss Hudson, what about airplanes, paper airplanes? I was like, yeah, that's a great example. As you throw a paper airplane, it glides slowly down through the air because the air is catching on its wings. It still falls because of gravity, but what makes it fall slowly is drag. Now, at the end of the video, I'm going to ask if you can think of another example where drag is used by people to help slow themselves down as they fall through the air. Let's see if you can think of that. But in the meantime, we're going to do this experiment. And for it, you need a sheet of paper. My paper is kind of thick, which is great because it's what you need to have. The thicker the paper, usually the better it works a bit. But you can use any regular paper, printer paper, construction paper, whatever you got. This is cardstock. That's why it's got these lovely blue lines on it. And you definitely need a ruler. And you definitely need a pair of scissors. And a pen or a pencil to make marks on the paper. And you're also going to need a paper clip. Now you can go big or you can go little, doesn't matter. But the paper clip adds a little weight on the bottom that helps our helicopter do what it needs to do for our experiment. So I'm going to do it, and if I go too fast, of course, stop me. This is a video. Yeah, you can pause me if you want to catch up. And like a paper airplane, if you make a paper helicopter with me today and you don't like it, you can always do it again and adjust some things, experiment with it, right? All right, so we're going to start with a line that's not quite halfway across the paper, and I'm going to draw it for you. Like that. Perfect. See, it's not quite halfway. Halfway would probably be right about there. It's not quite halfway. Right across the paper. And then you're going to use the width of a ruler, and right above it you're going to do another line. All the way across. Oh, that line is terrible. Let me straighten that up a bit. There we go. Alright, you're going to do another line across the top so it makes like this bar. What did I say? I said the width of a ruler. That's how wide a ruler is. Do you see how I got my lines spaced apart? It's like the width of a ruler, right? Alright, so now I got two lines across. I'm going to do my other lines up and down the paper, right? So my first line I'm going to do is in the middle of the page. I'm just going to do a line like that. Do you see how it's not down here? We don't need it down there. We just need it up here at the top. All right, you got it? All right, here comes the tricky part. All right, there's always a tricky part. You're going to do 2 lines on the other side. Like so. You see how I did that? I just did 2 lines, and I kind of put the middle line in the middle, but I didn't draw it. Do you see that? So I've got 2 lines on the either side. All right. Now it's the cutting part, and I'm going to hurry because I don't want my video to be too long. I want you to be able to do this. The first line is easy. We're going to cut this center line, but only down until it gets to the other line. There we go. I'm stop. So it makes like little legs. You can't catch me. I'm the gingerbread man. See it? All right. Now I'm going to get my scissors, and I'm going to cut this line, but only until it gets to the other line. Do you see that? See it? I didn't cut all the way across. You don't want that. It'll just fall off. See how this looks like a capital letter T? I'm just cutting under this part of the T. Right here. And I'm going to do the same to the other side. I got to kind of look at it this time. I did that other one without looking. That's cool. There we go. All right, you see what I did? Right to the T. All right, you see it? So you should have 3 cuts. You should have 1 that makes the legs at the top, and you should have 1 and 1. So 3 cuts all together to the T. Now I got to fold it. All right. My first fold, I'm going to take this with my little cuts here, and I'm going to fold it over. So it folds in to the back. Then I'm going to fold the other side over till it folds in. So it makes like a stem or a trunk. Miss Hudson, you didn't fold onto the lines. Doesn't matter. As long as I've folded that all the way in, do you see? It's like a booklet. Like a stem or a trunk. All right. Then I'm going to fold my legs. Are you ready to fold legs? I'm going to fold one leg back towards me. And this one I make sure to fold on the line, right? Then I'm going to fold the other leg towards you. Make a good crease. Do you see what it did? Do you see it? See, I've got one folded one direction, one folded the other direction. Now I'm going to take my paper clip, and I'm going to put it on the bottom on my stem to hold it together. It puts a little weight on the bottom. So now I've got like the blades of a helicopter. So the only thing left to do is test it. Now you won't be able to see it, but you should test yours. And what we should see is if I let it go, it's going to fall towards the earth. Thank you, gravity. But as it falls, it will start to spin. And it spins because the air is pushing up against the wings that you have made and folded 2 directions. And that wind pushing up against it is our friend. So see how much you can get it to spin. Try some other things. Maybe put a little bit of weight on the bottom. Does it work better when you take the weight off? I don't know. You'll have to find out. Now, going back to our question, what other thing can you think of that people use that harnesses the power of and? Can you think of it? Starts with a P, ends with an air chute. Must be a parachute, which I look forward to building with you sometime soon. I hope you can. Thank you, science learners. I sure miss you guys. Talk to you later.